This video is for Chapter 12, Section 12.1 for the math activity Tracing Figures from Motions with Tiles. We'll rotate tiles and study the motions of points in the plane. In question 1, we have two tiles. The tile on the left is blue, and the tile on the right with the labeled vertices is green, and the green tile on the right moves. The green tile can be rotated around the blue tile as follows. It can rotate about the center of rotation here at point A up to the top, then again the center of rotation here at B to the left, then at the center of rotation C down to the bottom, and then around the center of rotation D back to the right. As the green tile rotates around the blue tile, vertex B will trace a path. For the first part of the motion of the green tile, point B traces out this dotted semicircle shown in the figure. Here's another view of that point tracing the first part of the path. I have just sketched here the square moving slowly up. So there's B, it's moved up some, it's still moving in the third one, and then in the fourth one it's all the way around. Hopefully this will help you see how that semicircle traced path occurs. Now for the actual work for part A. Outline the fixed blue square to establish its position. Then, with the help of a classmate or tracing paper if you're working alone, carefully rotate the green square around the blue square and mark the path of vertex B as the green square rotates all the way around the blue square. And remember, all the way around is illustrated in this figure. In part B, the final figure traced by vertex B can be subdivided into a large right triangle with 3 semicircles on the legs. Once you've actually sketched that path, that shape will make a little more sense to you. Sketch in the diameters of each semicircle and note how the region inside the path of vertex B can now be subdivided into 3 semicircles, 2 right triangles, and the original square. If the blue square has a side length of 1 unit, what is the area of the region enclosed by the path, the big shape that you've made? Now in question 2, in addition to rotating, the green tile can also slide up and along the sides of the blue square. And we have shown this in this diagram. The green tile can slide up, then it can slide left, and this will be the result. Slides and rotations can also be combined as the green square moves around the blue square. Here are 2 ways that the green square can move around the blue square and trace out a path, always for vertex B. It can slide up and then rotate 90 degrees about vertex D. It can then slide left and rotate 90 degrees about vertex D. It can slide down and rotate 90 degrees about vertex D, and so on. And you can see we have 2 sets of slides and rotations designed. Number 2A shows you 2 figures. You can see the blue tile in the middle of the figure. So which motion, 1 or 2, the ones we were just looking at, the combinations of rotations and slides, outlines a motion which results in figure 1 and which results in figure 2. And remember, we're tracing the path of vertex B. If the blue square has a side length of 1 unit, what are the areas of these regions in Figure 1 and Figure 2? Notice that you can divide the shapes into more manageable pieces for calculations, as we did with the previous problem, and I've drawn in a few lines here to let you see that this is 2 semicircles, 3 squares, and 4 half-square right triangles. It's very interesting to think about motions in the plane. I hope you have fun with Math Activity 12.1.